increasing and decreasing functions. Let's consider the graph of y is equal to f of x. It's a part of the parabola. Okay, just for an example, I have taken part of the parabola. That is the right part of the parabola from the stationary point. So based on this graph, let's discuss two questions here. The first question is, as the value of x increases, the value of y becomes dash. What happens to the value of y? And the question number two is, the sign of gradient is dash. Means the sign of the gradient of any point on this curve is always dash. Okay. So when we look at the first question, as the value of x increases, the value of y, and the second question is the value of the gradient of any point is always dash. So let's answer these two questions. When we think about the first question, look at the graph. When x increases, means always the graph moves from left side to right side. So when x increases, you can find an increase in y, isn't it? Okay, so that's the answer for the first question. As the value of x increases, the value of y also increase. Okay, and when we think about the second part of the question, the sign of gradient of any point is always dash. So here, based on the first one, you can get the second answer. So here you can find when x increases, y also increase. So both are in the same direction. So we can say that the gradient is always increases. And you can see the graph goes from left to right in the positive direction. Means the upward direction. Yes. And this type of functions, when we consider a function like this, means a function which has a positive gradient. A positive gradient stands for a gradient which is greater than 0, can be called as an increasing function. Okay, so as the gradient increases, its derivative also increases. That means derivative must be greater than 0, because derivative is another alternative for gradient. Okay, that means the derivative dy by dx will be greater than 0. Yes. So in conclusion, we can say that when we consider an increasing function graph, its dy by dx is greater than 0. That means in increasing function, dy by dx is greater than 0. That means the gradient is so for an increasing function, the gradient is positive, so gradient is greater than 0. That means the derivative is greater than 0. So dy by dx greater than 0. And when we consider a function like this, by seeing this graph itself, we can understand this is the left side of the parabola. Here, as x increases, what happens to the value of y? And what about the gradient? And when you look at the graph, clearly you can understand when x increases, the y decreases because it goes in the downward direction. When we look at from left to right, it moves in the downward direction. So when x moves right side, y goes down. That means y decreases. So from these two concepts, as x increases and y decreases, you can get the concept of the gradient clearly. As the gradient decreases because x increases and y decreases. Both are in inverse proportion. So we can say the gradient or slope decreases. Okay. So the gradient decreases. What do you mean by gradient decreases? Means nothing but the derivative decreases. That means the gradient is less than 0. That means the derivative is less than 0. Or it means dy by dx is less than 0. So for a decreasing function, gradient is less than 0 or derivative is less than 0, and you can say clearly dy by dx is less than 0. Such a function is called as decreasing function. And when you consider this parabola graph, here you can find the left side as a decreasing function and the right side as an increasing function. With you can identify the left side is dy by dx less than 0 and the right side is dy by dx greater than 0, and the axis of the parabola or vertex of the parabola, that point is the stationary point which comes as the minimum point or maximum point. So the right side is increasing and the left side is decreasing, and the axis or vertex is the stationary point. So in left side we can understand dy by dx is less than 0, right side is dy by dx greater than 0, and the vertex stationary point meant for dy by dx equal to 0. Okay. Let's consider this graph. Okay, in this graph the first part is the increasing part, so we can say dy by dx greater than 0, and it meet to a stationary point, that means dy by dx equal to 0. And the third section is a decreasing part, there dy by dx less than 0, it reaches to a stationary point, so there dy by dx is equal to 0, again it goes to an increasing function, there it is dy by dx greater than 0, and the remaining part goes as stationary there. The function f is defined by f of x is equal to 1 by 3x plus 2 plus x square for x less than minus 1. Determine whether f is an increasing function, a decreasing function, or neither. So for this, let's consider the function f of x is equal to 1 by 3x plus 2 plus x square. And as it is not in the standard form, we need to convert 1 by 3x plus 2 in the standard form as 3x plus 2 the whole raised to minus 1 plus x square. Now find the first derivative of this function as f dash x, because for increasing or decreasing function we need f dash x. Actually we need to use the chain rule for this, but we are using directly. So as per n into x raised to n minus 1, we can write it as minus 1 into 3x plus 2 the whole raised to minus 1 into the derivative of 3x is 3 plus x square becomes 2x raised to 2 minus 1. So that f dash x is minus 1 into 3 is minus 3 of 3x plus 2 the whole raised to minus 2 plus 2x. That is f dash x is equal to minus 3 divided by 3x plus 2 the whole square plus 2x. Now we need the number line where minus 1 is a critical value, and minus 1 makes two parts of the line segment, which is x less than minus 1 and x greater than minus 1. And as per the question, our required region is x less than minus 1. Now let's take a convenient point from that. For me, I'm taking a point minus 2 as the convenient point. Now let's take x is equal to minus 2 and substitute x is equal to minus 2 in the first derivative f dash x, so that we get the value of f dash x as what we get the value minus 3 divided by 16 minus 4. Yes, minus 3 by 16, 2 into minus 2 is minus 4, which is a negative value. That means f dash x is smaller than 0. Hence f dash x is a decreasing function. So here, for proving f dash x, we get 1 mark. Sorry, it's not 1 mark, it's 2 mark. I've typed there 1 mark. It's not 1 mark, it is 2 marks. That's the maximum mark for finding f dash x. And to show it is decreasing, or to check it is decreasing, we get 1 mark. That means for dy by dx less than 0, we get 1 mark. Okay. Find the range value of x for which y is equal to x cube plus 5x square minus 8x plus 1 is increasing. As the function is increasing, dy by dx greater than 0. So let's find dy by dx, which is dy by dx is equal to 3x square plus 5 into 2x minus 8. That is, dy by dx is equal to 3x square plus 10x minus 8. As the function is increasing, dy by dx greater than 0, hence what we get, already we have dy by dx is 3x square plus 10x minus 8. That means 3x square plus 10x minus 8 is greater than 0. Now we need to calculate the critical values in which 3x square plus 10x minus 8 equal to 0. So here, for calculating that, you can use either factorization or quadratic formula or completing the square, so that we get two values of x. X is equal to minus 2 by 3. Sorry, x is equal to 2 by 3 and x is equal to minus 4. Now let's mark those points on the graph. So this is x is equal to minus 4 and x is equal to 2 by 3 is the next stationary point, which is the next critical value. That is, x is equal to 2 by 3. And when you look at the graph, you can identify the increasing function. Our question is increasing function. So increasing function is here and also here. Okay. And which represents, you can find what is the first part. It is smaller than minus 4, right? Isn't it? The first part is smaller than minus 4 and the second part is bigger than 2 by 3. Okay, so let's make it as the first part. That part is x, which is smaller than minus 4, and The second increasing part is bigger than 2 by 3, which is x greater than 2 by 3. Yes. Okay. Hence, we can conclude our question that the range values of x are x smaller than -4 and x greater than 2 by 3.